Hi everyone. Thank you for having me. What an amazing event it's been today as well. Like every single talk has just been absolutely out of this world. So thanks for CSS Vienna webclerks for putting it on and inviting me along to speak as well. So let's just dive straight into it. So CSS is often labeled as not being able to scale or work in large projects. And this is when we often get some sort of JavaScript-based solution recommended to us, or some creepy reply guy will turn up in your Twitter mentions and recommend Tailwind CSS to you. And these things are absolutely fine. You use whatever you need to use to get the job done. I get that. But you do have to be aware that these do have a heavy footprint a lot of the time as well. So I like to do this weird thing. I'm a bit of an odd person. Those of you who follow me on Twitter already know this. I like to do what I call my annual Tailwind CSS audit. And that's not because I don't like Tailwind. I actually really like Tailwind. I think it's a brilliant tool, especially for prototyping. But my concern with Tailwind is that it's incredibly popular, just like Bootstrap previously. Now, the thing for me is that we have to keep an eye on what tools are currently really being used a lot in the community. So with Tailwind, I'd like to do a lot of it, and I'd like to see what the distribution size of the CSS is, because even though people will come in and say, "Oh, we use purge CSS," or "Oh, we use the config file," just like with Bootstrap, quite a lot of people will just use the distribution build of the CSS and then build on top of it. And as you can see on this slide, and I'll read it out anyway, it's 80,936 lines of CSS and 102 kilobytes in weight. And that's the normal build. So that's the non-minified build. So you might be lucky and they might use the minified build. But still, it's pretty eye-watering. But I'm digressing slightly. Let's dig into what I'm actually talking about today. That is important context, but let's talk about some more fun CSS stuff instead. What's often forgotten when we're talking about these modern tools is that the solutions are usually only useful in greenfield projects or in new, fancy JavaScript powered SPAs, or one of the new static site generator sites, Eleventy, Gatsby, whatnot. The point I'm making is that quite often you can start with a blank slate in order to use one of these tools. Now, for context, in the real world, it's estimated that WordPress powers around 36% of the internet. That's the entire internet. And that's still rising too. Now, compare that to a paltry 0.3% of websites that use React, for example. It's important to keep those figures in mind. So in this talk, I'm going to talk to you about how I like to write CSS, which I hope could help quite a lot of folks. At least I hope so, because I've used this approach or an earlier iteration of it to power massive websites, tiny little blogs, mobile apps, and even intranet software over the years. And the methodology is called CUBE CSS. So let's dive in and see what it's all about. So first thing, what is CUBE CSS? What does this silly acronym stand for? Because it's a pretty rubbish name. I think we all can agree on that. But there's a reason for that rubbish name, because CUBE stands for composition, utility, block, exception. And CSS stands for, cascading style sheets. And the CUBE methodology is very much an extension of good old CSS rather than a reinvention. And this mantra is very seriously maintained too, as the cascading inheritance particularly play a big role. So let's start with the most important part of this methodology, and that's CSS, the language. And in this methodology, we embrace the power that CSS gives us rather than fight against it. And it's key to note its existence in the name, because some alternative approaches, such as BEM, which I've enjoyed for many years, I might add, they can veer very far away from cascading style sheets. and I love CSS. And I think its core capabilities are actually key to scaling it. Sorry, I said scale. And this thinking has taken a long time and lots of experience to embrace. CSS is an incredibly complex programming language to learn because so much of the working knowledge is less of syntax and more of how things work in specific domains, which are often browsers, but we're also talking stuff like print too. The cascade is itself magnificent because it enables us to write very little CSS and really isn't as scary as people often make it out to be. Sure, in the old days of Internet Explorer, the cascade was a bit tricky, but using old knowledge and experience as the base of modern approach is like feeding horse feed to a car. And the core of this methodology is that most of the work is already done for you with global and high-level styles. This means before you even start thinking about components, or in the case of CUBE CSS, blocks, your typography is mostly set, your colors are working great, and your elements are working harmoniously with each other. We use the rest of the methodology, CUBE, not to style everything, but instead to provide contextual styles that deviate from the common global system. CUBE CSS is in essence a progressive enhancement approach versus fight against the grain of CSS or a pixel pushing your project to within an inch of its life approach. And with that in mind, we'll move on to the first part of CUBE, and that is composition. And this is a really important part of the methodology. But before we talk about composition, we need to give ourselves a bit of context. So let's talk about design systems. And I'm lucky that I've been around these for around half a decade. And working with design systems has been one of the most valuable aspects of my career as a developer and a designer. And this is mainly because a design system doesn't just make you think at a micro level, but also at a macro level, because you have to make not just decisions about pixels, but also high-level organization decisions, which the design system helps to solve. Design system work is actually diplomacy work a lot of the time, rather than sitting and coding all day. And this is often where I see narrow, component-only tunnel vision fall short. And really, these approaches are less design systems, but more component libraries that solve a much narrower cohort of problems. Often, in more recent conversations, read tweet threads about design systems, stuff is often very micro-optimized. And this is fine because if it works for folks, it works. But I would issue a warning. The Lego blocks analogy isn't that relevant in the wider context of design systems. It is very useful at explaining a component's role in an overall project, though. And I mention all this not to sound all smart about design systems. There's enough white guys who say, try and act smart about these things. But because even if you break your design system into tiny molecules, it's still going to be applied in a larger context at some point. And that should never be forgotten, but so often is. So just on that big old wide deviation away from composition, but that design systems part was important because this is what I think the composition layer should do in this methodology. It should provide high-level flexible layouts. It should determine how elements interact with each other. And finally, it should create consistent flow and rhythm. And what it shouldn't do is provide visual treatment, such as color or font style. It shouldn't provide decorative styles, such as shadows and patterns. And it shouldn't force a browser to generate a pixel-perfect layout. The best way to look at composition is that it's often a whole page view. And I've found over many approaches within many projects over the years that wider composition often trumps micro-optimizations. And the composition layer of CUBE CSS exists because of this. And it was born during this project, Every Layout, which is a book that I co-authored with my good pal, Hayden Pickering. And the core methodology of our book was, for layouts, we'd find the most robust solution by simplifying and distilling the problem. And then we'd hint the browser rather than micromanage it to allow the browser to call the shots, knowing what it knows about the current context it finds itself in, based on a small rule set that we gave it to achieve what we wanted it to achieve. And this results in very solid layout systems that work upwards with progressive enhancement at the forefront. And that's every layout. And that is how this composition layer sort of evolved over that project, like really changed how I looked at CSS. And that's big thanks to how Hayden operates as well. So if you want to have a look at that, it's at everylayout.dev. Anyway, back to this. What do I mean about composition? Let's take a look at this classic layout. So what we've got here is got a hero element, and then we've got 3 card elements. Very standard edition stuff, very similar to Cassie's first slide on her talk. But this is an easy to communicate example about how this sort of thing can work. So you've got your elements here. Now, in some methodologies, you might apply these layout rules to the elements directly, but not in Cube. This is what the composition looks like. To think of a composition is to think of a skeleton. So what we do is we create slots for our components, or in this case, blocks, to sit in. And it shouldn't matter what goes inside of each of these slots. All we're doing is setting some rules and saying, for example, to this hero, right, you try and fill the viewport, and the rest of you split the space in between equally and add some nice gaps in between you. So what it means is that we've got this sort of example here. So we've got that same hero element, and we've got 2 of the cards. But what we've done is we've added a call to action in the middle instead. And there's been no dramas for that. Everything's just worked as it is. And now imagine if we had something like container queries too, we could really utilize some power with this compositional system. And composition isn't just full pages or full layouts within sections. It's also key within blocks or components too. So take our card here as an example. You probably have some flow content in there somewhere, just like in that illustration, where a heading and summary hang out together. Now, what you could do is you could add a class to every single element in there and micro-optimize how they behave with each other. Or you could do this. This is what I like to call the flow component, or the flow utility more accurately, because it does one job, and that will become clearer later in the talk. Now, how this works is we've got a lobotomized owl selector. And what I do is I add a little bit of extra complexity by adding a direct children selector in there as well. So what this says is, in the flow utility, for every direct child sibling, so not the first one, everyone that follows it, add some margin top to it. Now, the first thing we do is we look for a custom property value of flow space. And then, thanks to CSS's amazingly, forgiving nature, we can pop a little fallback in there as well. So we can say, look, if flow space isn't defined, then just put 1em of space there instead. Now, what 1em will be is the font size of whatever that element is. But for argument's sake, let's just say 1em is 16 pixels right now. So we pop flow in any element, and it'll automatically pick out those elements for us. So what we can do then is we'll apply it to our HTML like so. So we've got our card, and then we've got our card content element inside of it. And on there, we pop the flow utility. And that means now we can put whatever the hell we want inside that card content box. It doesn't matter. We could put headings, we could put lists, we could put another image in there, we could put buttons, whatever you want to put in there. We'd know, because we've got flow in there, and as long as the element isn't inline, of course, it'll have that consistent margin added to it. And this is the sort of flow and rhythm that I was talking about at the start of the talk. So that segues us nicely to utilities. If utilizing the cascade is the backbone of this methodology, then utilities are the shoes that help it to walk comfortably. A utility in the context of CUBE CSS is a CSS class that does one job, and it does that one job well. This CSS class, more often than not, will have one CSS property defined. But it could also have a few properties defined in a concise group, like this example of a wrapper utility. This handy utility provides a consistent max width, a padded container that sits in the middle of the viewport when the viewport is greater than 60 rem wide. It's one job and it's done well by the utility. Now, with the utility part of this methodology, design tokens fit hand in hand with it. And to just give you a quick explainer of what a design token is, they're a concept by Gina, who's a design systems legend. And this completely transformed how I think about design systems as a whole. And here's a direct quote about what design tokens are by Gina. Design tokens are the visual atoms of the design system. Specifically, they are named entities that store visual design attributes. We use them in place of hard-coded values in order to maintain a scalable and consistent visual systems. So design tokens are really useful because they allow our systems to be scalable. Sorry, I said scale again. And this is the core with this methodology, CUBE CSS, because we take those abstracted values and apply them to our context with utility classes where possible. So for example, let's say our primary color for our project is a nice hot pink or magenta, and that's FF00FF. Now, this could be defined outside of our project. It could be defined in a database, a JSON file, or it could even be defined in a spreadsheet, which I've seen recently, which is really cool. Now, because these are often defined outside of the project, we need a middle step to turn them into CSS for us. Now, what I like to do is turn them into Sass, which then in turn turns them into utility classes. But in some projects, you might just want to turn them straight into utility classes. A little bit like this. So we've got 4 utility classes that have been generated from our design tokens here, and they're set background or color. And they're set either the background, the primary or the secondary, just to keep things nice and short. Now, we can then apply them to our elements like so. Now, for those of you who like to use stuff like Tailwind CSS, this is going to start looking pretty familiar. And I'd lie if I didn't say this is inspired by Tailwind. One of the most useful things I found Tailwind to do was to actually maintain design tokens in a project for us, or at least translate them into CSS for us. So applying our design tokens like this allows us to define things once and apply them everywhere. It reduces repetition, and most importantly, it reduces overall bundle sizes. And just like composition, we'll have a quick look at what utilities should and shouldn't do. So what they should do is apply a single CSS property or a concise group of related properties. Extend design tokens or maintain a single source of truth. Finally, abstract repeatability away from the CSS and instead apply it in the HTML, which more efficiently comes down the pipe. And then define a large group of unrelated CSS properties. We definitely don't want this to happen because then you're in the mantra of creating blocks instead. So for example, a utility that defined color, font size, and padding would make more sense to be something more complex like a block. And this should definitely not be used as a specificity hack. I cannot say that word because I'm from Yorkshire, so you're just going to have to pretend that I said it right. So for example, setting all properties with an important flag would undoubtedly cause problems in the long run. Just for as an aside, I can always say that word when I rehearse talks, but the second I actually do them live, it just fails me every single time, this damn accent of mine. Anyway, block. So this is the next part of the methodology. And what a block is it's a building block or your component. It's your card or your button. If you've already used BEM before, the definition is almost identical. But a block at this point is really a minor thing in CUBE CSS because so much has been handled by the other parts covered, CSS, composition, and utilities. And what that means is if you choose to write your CSS with this sort of methodology, You'll probably find that your block CSS is tiny because of this. And a major difference between BEM and Cube is that whatever goes inside of the block is open season. And this is because, as mentioned previously, your global CSS, your composition rules, and utilities have most likely done most of the work for you. So having formal elements at this point is sort of redundant. Doesn't stop me though. I still personally like to use the BEM syntax for elements like this. So you got my block and then 2 underscores and then my element. And this is mainly a preference that stems from years and years of working with BEM. So it's how my brain's now programmed. But you could quite comfortably give each element flat selectors or even apply HTML element styles too. The best way to look at a block is, instead of it being like a BEM block where you've got strict element relationships, a block in Cube is a bit like a namespace. It's like a safe haven to create some specificity, which I said right this time, where you need it. So it really shouldn't matter, again, because your global CSS, your utilities, your composition rules are doing the hard work for you. So think of blocks as a sort of override instead. So what a block should do is extend the work already done by the global CSS, composition, and utility layers. It should apply a collection of design tokens within a concise group. And what I mean by that is, for instance, I run a SAS library called Gorka. And what that does is it generates utility classes for you, but it also provides you with SAS functions and mixins to apply utilities directly in a block if you need it. It's a SAS library that was essentially built for CUBE CSS. And then finally, the last thing a block should do is create a namespace or specificity boost to control a specific context. Now, what a block shouldn't do is grow to anything larger than a handful of CSS rules, sort of maximum 80 to 100 lines. If you're getting anything larger than that, I'd say you're getting a bit too complex. So you start to think back, well, can global CSS help with this? Can utilities help with this? Can composition help with this? And if not, then maybe do we create 2 different blocks in one instead? And then finally, a block shouldn't solve more than one contextual problem. So for example, inside a block, you wouldn't style a card and a button in one file. You'd create 2 blocks for each one of them. So you create a card block and a button block. So finally, in this tour of what the Cube bit stands for is exceptions. Now, these are little variations mainly to a block, but they can apply to all sorts of things. So for example, you might have a reverse state or an inactive state. And for these exceptions, we use data attributes instead of class modifiers. So take this card as an example. By default, it's a standard edition card. When we add a reverse state to it, the image is at the bottom and the content is at the top. Now we add the exception using a data attribute like this. And here we've got data state equals reversed. Now the reason why we use a data attribute is because it's easily translated between the 3 pillars of the web: CSS, HTML, and JavaScript. It can easily be understood by all of them. It doesn't interfere with assistive technology. And my favorite part is that a data attribute can only ever be one value too. So it enables you to work with finite state machines, which give you super resilient state-driven front ends. Now, what I found with BEM, and this is what really started me thinking about this sort of methodology, was that with BEM, you can never guarantee what state your block would ever be in, because you could put whatever modifiers you want on it at any time. And that, you might think, well, don't add that many modifiers. But when you're working in a humongous team of developers, a lot of who are not front-end developers, things can get out of hand really quickly. But whereas you've got a finite state that you're working with instead, you can guarantee that your block or utility or your composition layer are always going to be in one state at one time. Just an FYI, this reverse state reverses the content with Flexbox. Just be very careful changing the source order of content, especially when there are focusable elements in there as well, like links and buttons. And this example is mostly fine because if you remember, we only had a heading and a summary. But if you start flipping focusable elements, it can get really confusing for people who use assistive technology. So as always, use your best judgment where you can. So what we'll do is we're just going to finish this talk up with a look at the principles of the methodology instead, because the principles are arguably the most important part of them. And the overarching principle of CUBE CSS is simplicity and pragmatism. There's a lot of benefits to letting the right tools do their job without any intervention. The browser in CUBE CSS is hinted rather than micromanaged to do what it knows best in the context it finds itself in. Browsers are incredibly powerful and incredibly smart. So all we really need to do is just to give them some guidelines and say, look, do your best with this, but if it all fails, then just stack things, it'll be fine. Progressive enhancement is always at the forefront of these things. Has the user got an old browser? That's not a problem with CUBE CSS because progressive enhancement is built right into the core of the methodology. Let's take this example here. I like to use the term minimum viable experience. And what that does is it accounts for very old browsers by default, because the first part of whatever you build is what's the minimum that this thing needs to do and what's the least power in order to achieve it. The principle of least power is so powerful, ironically. So what we do is we extend on the minimum viable experience with more modern capabilities. So where we got support, we add Flexbox and add grid, etc. Because CSS is forgiving, we don't have to add any hacks or anything like that. We can just write CSS normally and it will enhance itself by default. So I'll just explain what you're looking at on this diagram here. We've got this diagram is often used as a minimum viable product example, but I like to use it for progressive enhancement. So on the top row, we've got a car, which is the deliverable at the end. But up until the point where you have a full-fledged car, it's pretty useless. So there's one wheel, then there's just two wheels and a chassis. Arguably the third one you could use as a car. It's just got no roof or windows, but you could probably still drive it. And then finally get a car. And this is how a lot of front ends are built these days. You have to have everything in order for it to work. And if just one thing fails, the whole thing fails. And that's just not a resilient way to build things, especially in a hostile environment like a browser. So then you've got this bottom row, which is the progressive enhancement approach instead. So the first thing we've got is a skateboard, and the skateboard will do the job for us. It'll get us from A to B. It might be a bit slow, but it'll get us there. And then you've got a micro scooter, which is a bit quicker because you've got your handlebars, so you're a bit more confident maybe. Especially me, I don't skate anymore because I'm a bit too clumsy and old. And then you've got a push bike, and that's even quicker because then you've got the power of the pedals. And then finally, you've got the optimum experience, which is a motorized scooter. And I've picked that deliberately because often with progressive enhancement, the end product is much lighter and simpler than without progressive enhancement, because progressive enhancement forces you to think of things in a simple way rather than an over-complex, over-engineered, and very smart look at me way. So without polyfills and hacks, we've produced much less CSS by proxy. And by using the progressive core of CUBE CSS methodology, we get this really resilient front end out of it. And the core simplicity also calls for a reduction in abstraction. By using CSS for what it's good for, we assign most of the style rules at a higher level, which are supported by composition styles, utilities, then finally blocks and exceptions. CUBE CSS has a very flat, inclusive structure, which makes it predictable and as easy as possible to pick up, even if you're new to it. Whether you like to author your CSS with Sass, Less, Post CSS, or even CSS in JS, the principles and methodology of CUBE CSS remain. CUBE CSS is a completely tool-agnostic methodology because it's more of an organizational methodology rather than a tooling methodology. As long as the output is CSS at the end, it's all good. Hopefully this quick tour of CUBE CSS has, if you considered CSS to be a programming language that doesn't scale, beneficial. If someone tells you that CSS can't scale, put it simply, they're lying to you. They're missing heaps of context about their organization, which is usually the root of the problem rather than CSS the language. CSS is awesome, especially when you use a pragmatic methodology like CUBE CSS. And if you want to learn more, head over to cube.fyi, where there's loads more detail on how things are supposed to be, and then a high-level blog post about it as well. Now, we use CUBE CSS in a course that I've recently released as well about learning to build an 11 site from scratch. Now, if you use the coupon code CUBEPAL, you get 50% off just for being cool and coming to this event today. So the link's there. If someone wants to put that in the chat, that'd be awesome. And then this is what you build inside of that course. And we use CUBE CSS to build it. And it's a really fun way of learning how to build that sort of stuff. So anyway, thank you for having me. Thank you, everyone. Cheers.